Welcome back to seventh part of identity related to multiple angle. Identity number 32. I'm pretty sure you have already watched all the identities. So if you haven't watched, then pause this video, go back, watch all the videos, and only resume this video. Because without watching the previous videos, I think it will be difficult for you to understand, correct? So in 32 number, we have root 3 over sine 40 degree plus 1 by cos 40 degree equals to 4. So we are going to choose left hand side at first. So left hand side, we have root 3 over sine 40 degree plus 1 over cos 40 degree, isn't it? This question can be solved by two ways. The first one, root 3 becomes tan 30 degree. No, tan 60 degree, right? Tan 60 degree, and tan 60 degree becomes sin 60 by cos 60. Then LCM, this question by that method is already shown or given in the example. So you can go and try to understand it by yourself. But still, if you get any confusion, then write down in the comment box. I will again make another video and I will do the same question by that method also. So another method is that let's take LCM. So sine 40 degree dot cos 40 degree, that's a LCM, and work of fraction, all of you know better. So this becomes root 3 cos 40 degree plus 1 into sine 40 degree means sine 40 degree. So we are going to apply one technique at the numerator and as well as at the denominator. So what can we do? Can you write here 2 into 1 by 2? 2 into 1 by 2, nothing can change. 2 into 1 by 2 means 1. So first write here 2 into 1 by 2. Right, and that is root 3 cos 40 degree plus sine 40 degree. Okay, and here 1 by 2, 2 sine 40 degree dot cos 40 degree. Technique. Why? Very soon you will understand, okay, in the next step. Just 2, here is 2 already, this 2, and 1 by 2 goes inside. So this becomes root 3 by 2, this 2, okay, cos 40 degree plus 1 by 2 times this means 1 by 2 sine 40 degree. Alright, and here 1 by 2 sine 2a, isn't it? 2 sine dot cos a means sine 2a, and here is 40 degree at the place of a, so this becomes 2 into 40 degree, isn't it? Next step, just you can see here. Little bit, I'm just going to shift left. Now see carefully here. This 2 and that 2. See carefully. This 2, you can see this 2 and that 2 becomes 4. Okay, so here it becomes 4. Listen, how 4? This 2 and this 2. Okay, not to forget that. And inside the bracket, here, root 3 by 2. Root 3 by 2 means sine 60 degree, isn't it? So we can write sine 60 degree. Here is cos 40 degree. Here plus 1 by 2. 1 by 2 means sine, no sine, cos 60 degree, isn't it? Cos 60 degree. So you can write here cos 60 degree and then sine 40 degree. Okay. And here this 2 has already gone up. So here we got 4 and sine 2 into 40 degree. That is sine 80 degree, isn't it? Next one, that's 4. Remember one formula, compound angle formula, sin A dot cos B plus cos A dot sin B. Yes, you are right. Okay, sin A plus B. So we can write here sine 60 degree plus 40 degree. Okay, and here is sine 80 degree. Now we have here 4 sine 100 degree. 100 degree over sine 80 degree. Okay, sine 100 degree. So we can write here as sine 180 degree minus 80 degree. Can we write or not? Because 180 degree minus 80 degree is 100 degree. Sure. that is sine 80 degree. Okay, remember cast formula. If you don't know cast formula, then I have already made one video, so you can search, in my digital maths academy, because it's your channel. Okay, so we can write here 4 sine 180 degree minus a means sine a, because it goes in second quadrant. So we can write here sine 80 degree and over sine 80 degree, isn't it? Just remember here sine 180 degree minus a equals to sine a. Cast rule. Next one, these two parts we cut, and the remaining we have here equals to 4, and that's our right hand side and root. Clearly? Identity number 33. So let's choose left hand side. We have here left hand side equals to cosec 10 degree minus root 3 sec 10 degree. We have to change cosec and sec into sine and cos. So cosec equals to 1 by sine. So it becomes 1 over sine 10 degree minus root 3 by cos 10 degree. This has become same as you have recently seen in 32 number, isn't it? Right? 32 number? Right or not? You can see that here, same. Yes or not? So we can solve it by two ways. One way you have already seen in a 32 number, so you can take LCM and you can go ahead. And the second way is root 3. Here is root 3, so we can write root 3 as tan 60 degrees, isn't it? Let's do. So we can write here 1 by sine 10 degree minus tan 60 degree over cos 10 degree. Okay, 1 by sine 10 degree minus tan means sine by cos, so this becomes sine 60 degree over cos 60 degree dot cos 10 degree. Next step, LCM. LCM means here is sine 10 degree dot cos 60 degree dot cos 10 degree. Right? So all of you know the work of fraction, very nicely. So you know that this work of fraction. So we write here cos 60 degree dot cos 10 degree minus sine 60 degree. Here cos 60 cos. So we write here sine 10. Isn't it? Just see carefully, okay? Now it's in the form of formula, right? Cos A dot cos B minus sin A dot sin B. You remember? Yes, you are right. So genius. Okay. Cos A dot cos C minus sin A dot sin A means cos A plus B, right? So we write here cos A means 60 degree, B means 10 degree, cos A plus B over here. See carefully. Cos 60 degree. No, cos 60 degree means 1 by 2. That's cos 60, right? Listen. And then you have sine 10 dot cos 10. Clearly? Okay. Let me do at another side. Now here, see. Here 1 by 2, this 2 goes up, it goes at the numerator. So this becomes 2 cos 70 degree. Can you write or not? See carefully. These two, it goes up, it becomes 2 cos 70, 60 plus 10 means 70 degree. And you have sine 10 dot cos 10, isn't it? So which one is missing here? Yes, you know better. 2 is missing, so we can write here 2 sine 10 dot cos 10 over 2. Can I write or not? These two balanced already. But this 2 is up here, right? Not to forget that. Okay, another. When this 2 goes up, 2 to the 4 becomes. Here becomes 4. And here is cos 70 degree. And here 2 sine dot cos B, 2 sine dot cos A means sine 2A. Here becomes sine 2 into 10. Right? Correct? So this becomes 4 cos 70 degree over sine 20 degree. Okay. Once again, cast rule came. So 70 degree, we can write here 4 cos 90 degree minus 20 degree. Can you write or not? Sine 20 degree. Sure. Because 90 minus 20 equals to 70. Then apply formula. Okay. Cos 90 degree minus A equals to sine A. It lies in first quadrant. Here is 90. So trigonometric ratios will be changed. So this is 4 sine 20 degree over sine 20 degree. Write down inside the bracket formula. Okay. Here cos 90 degree minus A equals to sine A. First quadrant always positive, and you can cut these two parts. Remaining you will have here 4, that's equal to right hand side, and proved. Okay, you can write here also inside the bracket, formula here. You can write, doesn't matter. This depends on you, okay. You can write here. Here cos A dot cos B minus sine A dot sine B equals to cos A plus B. It's clear? Identity number 34. It looks danger, but it's very easy. Under root of 2 plus, under root of 2 plus, under root of 2 plus 2 cos 8 theta equals to cos theta. So first of all, we have to choose left hand side, correct? Left hand side equals, it's very easy, okay? Left side equals to under root 2 plus again under root 2 plus again 2 plus 2 cos 8 theta. Alright, we have to begin from here, right? This part. So we write here this under root as it is, then there's a 2 again plus, this is 2 plus again here. See carefully. Can we take 2 common? Yeah, between these two we can take 2 common, right? Here is 1 plus cos 8 theta, right? And 8 can be written as 2 dot 2 theta. Sorry, 2 dot 4 theta. Can you write or not? Because 2 for the 8 you have already, and 2 is taken common. Next one. There's a, once again you have now here, there's a 2 plus, this is 2 plus, here is 2, okay, into 1 plus cos 2 theta. Remember one formula, okay? 1 plus cos 2 theta equals to 2 cos square theta, right? So you can add here 2 cos square, and at the place of A we have 4 theta, so we write here 4 theta. Okay, not to forget that, okay? See carefully. 1 plus cos 2 theta equals to 2 cos square theta. How? It's very simple, cos 2 theta, equals to 2 cos square theta minus 1 plus 1 will cancel, 2 cos square theta will remain. It's very simple, it's not so harder. Okay, next one, next part. That is first root to second root. Another 2 plus here 2 to the 4 cos square 4 theta, right? And square root of 4 is 2, and square root of cos square 4 theta is cos 4 theta. Just we can write here under root 2 plus again under root 2 plus, and this becomes 2 cos 4 theta. Clear? It's very simple, because square root of 4 cos square 4 theta is equal to 2 cos 4 theta. Likewise, just look here. Again, same process, same, the process we are going to repeat. Again, take 2 common, 1 plus, again 4 theta becomes 2 dot 2 theta, same. Okay, here is 2 plus, here is 2 into, again 1 plus cos 2a equals to 2 cos square a. So that is 2 cos square a, and at the place of a we have 2 theta. Again 2 plus, here is 4 cos square 2 theta, This becomes 2 plus 2 cos 2 theta, right? Same process. Okay, next one. Again, take 2 common. Here is 1 plus cos 2 theta. Okay, 2. Again 1 plus cos 2 theta means 2 cos square theta. 2 cos square theta, right? 1 plus cos 2 theta means 2 cos square theta. And it is a 4 cos square theta. That is 2 cos theta. Look, what's at the right hand side? Did you get or not? 2 cos theta, right? Here is the right hand side. You can see that. Okay. And here we got 2 cos theta very clearly. It's clear? Okay. Now, right here equals to right hand side and put. Isn't it? Identity number 35. Sin square alpha minus sin square beta over sin alpha dot cos alpha minus sin beta dot cos beta equals to tan alpha plus beta. With respect to this chapter, that's multiple angle, we have to choose right hand side only. But it can be solved by choosing left hand side. But some another formula can be applied when you choose left hand side. But with respect to this chapter, multiple angle, we have to choose right hand side only. Let's choose right hand side. Right hand side equals to tan alpha plus beta, right? But once again, I will solve this identity when I'm solving some identities of another chapter. Another chapter means there's a conditional trigonometric identities, and transformational trigonometric identities. Okay, here tan a plus b. So we are not going to apply the compound angle formula of tan a plus b. So tan is changed into sin by cos. So we can write here sin alpha plus beta over cos alpha plus beta. Alright. Now let's multiply the numerator and the denominator by sin alpha minus beta. Okay. Clear? Okay. Now we are going to apply compound angle formula. So sin alpha plus beta means sin a plus b, that is sin alpha dot cos beta plus cos alpha dot sin beta. Here alpha is at the place of a and beta is at the place of b. Similarly here also sin alpha dot cos beta minus cos alpha dot sin beta over cos alpha plus beta, that's cos a plus b, cos alpha dot cos beta minus sin alpha dot sin beta. Isn't it? Cos a plus b should be minus in the middle. Here sin a minus b. Okay, sin a minus b means sin alpha dot cos beta minus cos alpha dot sin beta. It's clearly? Okay, next one. Look at the numerator. A plus b, a minus b. Yes, a square minus b square. So sin alpha dot cos beta is at the place of a and cos alpha dot sin beta is at the place of b. So a square minus b square means here sin square, no, not square here, sin alpha dot cos beta its whole square minus cos alpha dot sin beta its whole square, a square minus b square. And here at the denominator, just multiply. Okay, so this part should be multiplied by this part, so cos alpha cos beta, sin alpha cos beta. So cos beta becomes cos square beta, isn't it? So remaining we have sin alpha cos alpha. So sin alpha dot cos alpha into cos square beta. Sure, understanding? Okay, now this into that part. See which one is matching? Cos alpha, right? So we write here sin beta cos beta minus sin beta cos beta dot cos square alpha. Clear? Okay, now same from with there's a minus sin alpha dot sin beta. Okay, with this term by this term. Okay, we are just going to multiply. Look carefully. Minus, which one is matching here? Sin alpha, right? Sin alpha. So we write here sin beta dot cos beta dot sin square alpha, right? Okay, now this to that, minus minus plus, it will be plus. Okay, which one is matching here? So sin beta, okay, sin square beta. Okay, so we write here sin alpha cos alpha, sin alpha dot cos alpha dot sin square beta. Sure. Okay, please be more conscious at the time of multiplying. Okay, now here square of this becomes sin square alpha dot cos square beta. Here also minus cos square alpha dot sin square beta. Okay, now let's look carefully at the denominator. See, sin alpha dot cos alpha, right? And sin alpha dot cos alpha. You can see here. Can you take common here between these two parts? I'm just going to show you here. Okay, here sin alpha dot cos alpha, sin alpha dot cos alpha. Yes, you can take common, isn't it? Let's take common. Okay, when you take common, sin alpha dot cos alpha, right? Cos square beta plus sin square beta. Okay, next one here also. Okay, here also. See carefully, sin beta dot cos beta and sin beta dot cos beta. Yes, we can take common very easily. So when you take common, here is negative sign. So we write here minus sin beta dot cos beta, and we have here cos square alpha, and this minus sign becomes plus because we have taken minus common, and we have here sin square alpha, right? Okay, now next part, see carefully here. Actually, when you see the right hand side, or no, here left hand side, we have sign only at the numerator, isn't it? See here, sign only. So we have to change cos square into sin square, because we have sign only at the numerator. So here we have okay, so sin square alpha and cos square beta becomes 1 minus sin square beta. Here also this is sin square beta, and cos square alpha becomes 1 minus sin square alpha, correct? And now at the denominator, this parts gives you 1, so we have here sin alpha dot cos alpha minus into 1, better to write here first of all, okay, into 1 because this is 1, minus sin beta dot cos beta into 1. Now just this becomes just multiply sin square alpha minus sin square alpha dot sin square beta. Here also minus sin square beta and minus plus sin square alpha dot sin square beta. Okay, and at the denominator we have sin alpha dot cos alpha minus sin beta dot cos beta. Okay, now these two parts will cancel, and the remaining we have here sin square alpha minus sin square beta. Okay, and at the denominator we have sin alpha dot cos alpha minus sin beta dot cos beta. Okay, just see, look at the right hand side here. We have, sorry, left hand side, sin square alpha minus sin square beta, sin alpha minus sin square beta, and sin alpha dot cos alpha minus sin beta dot cos beta. Okay, that's equal to right hand side, isn't it? Sorry, left hand side, and here we can write here root. Okay, just see carefully, okay, very nicely. It's clear. I hope all of you may have understood. Thank you for watching this video. If you have understood all the identities, then don't forget to like and share this video. And if you are new in this channel, then don't forget to subscribe and hit the bell icon. See you soon in the next part. Stay safe, stay healthy, have a good time.